On a Tuesday morning in September 2006, every screen inside NASA's Deep Space Network facility in Goldstone, California, went dark. At the same moment, all of them. And nobody who worked there that day has ever given a full public explanation for why. Not a power failure, not a scheduled maintenance window, not a software glitch that was later patched and documented, just silence. The kind of silence that, in a facility designed to listen to the farthest edges of the known universe, feels almost obscene. I want you to hold that image for a second. Rows of monitors, technicians mid-task, coffee going cold on desks, and then nothing. Because what came through those instruments in the hours before that shutdown, what was actually recorded in the data logs that have since been partially, selectively, carefully declassified, is the kind of thing that changes the way you look at the night sky. And by the end of this, it's going to change yours too. This isn't a story built on rumor or forum speculation. It draws from declassified government documents, on-record statements from former mission personnel, and the work of researchers who have spent decades trying to get straight answers from institutions that, for reasons we're going to examine closely, have never been particularly interested in giving them. There's a moment in this story, and we'll get there, where a former NASA communications engineer says something in an interview that stopped me completely. He doesn't scream. He doesn't wave his arms. He just says, very quietly, "We were told to stop looking." And then he pauses, and then he says, "So we stopped." That's where we're going. But first, you need to understand what was out there to find. To understand why the shutdown matters, you first have to understand what this particular mission was designed to detect, and just how sensitive the instruments aboard it actually were. By the mid-2000s, NASA had been operating a suite of deep space monitoring platforms that went well beyond the public-facing missions most people know about. The Voyager probes, the Mars rovers, the Hubble images that end up as desktop wallpapers. Those are the missions that get press conferences and children's book deals. But running alongside them, quieter, less celebrated, buried in budget line items with names that mean nothing to anyone outside the agency, were a series of signal monitoring operations. Platforms specifically designed to scan, filter, and analyze radio emissions coming from deep space. The one we're focused on was operating in a frequency range that, and this is important, so stay with me, had been internationally agreed upon as the most scientifically significant band in the entire radio spectrum. Not because it was easy to monitor, not because the technology was cheap, but because of what naturally produces signals there, and what that implies about what else might. The instrumentation aboard this platform was extraordinary by any measure. Dr. Caroline Reyes, a radio astronomer who spent 11 years working with NASA's Jet Propulsion Laboratory before moving to the University of New Mexico's Department of Astrophysical Sciences, described systems like this one in a 2023 paper on deep space signal methodology as having, and I'm quoting directly here, sensitivity thresholds capable of resolving narrowband emissions at signal-to-noise ratios that would have been considered science fiction 20 years prior. In plain language, this thing could hear a whisper from across the galaxy, and something whispered. The data fragment that survives in partially declassified documents describes a narrowband radio emission at 1,420 MHz, arriving from a fixed celestial coordinate, repeating, not randomly, not chaotically, but with an internal structure that, according to the signal analysis summaries that exist in the public record, bore the hallmarks of what researchers call non-thermal origin. 420 MHz. That number. That specific number is not arbitrary. And the moment you understand why that frequency matters, everything about this story shifts. But before I get into that, I want to flag something. Because there are going to be people watching this who are already reaching for the skeptic's toolbox. And honestly, good. Healthy skepticism is exactly the right response to a story like this. I'm not asking you to believe anything, yet. I'm asking you to follow the evidence carefully and decide for yourself what it means. So, 1,420 MHz. Here's something most people don't know. Physicists have long agreed, not debated, not theorized, agreed in a near universal scientific consensus that if any civilization anywhere in the universe were trying to say hello, they would almost certainly do it at 1,420 MHz. The reason is one of the most elegant ideas in all of science, and it starts with hydrogen. Hydrogen is the most abundant element in the universe. It's everywhere. Every star, every gas cloud, every drifting nebula. Hydrogen. And hydrogen atoms, in a specific quantum state, naturally emit radio waves at exactly 1,420 megahertz. This is called the hydrogen line, or sometimes the 21 centimeter line, because that's the wavelength that corresponds to it. Now, think about this from the perspective of a civilization trying to make contact. You need a frequency that any technologically capable species would know. A frequency that emerges from physics itself, not from culture, not from language, not from any arbitrary convention. A frequency that any intelligent being, anywhere, who had developed radio astronomy would have independently discovered. The hydrogen line is that frequency. In 1959, the year physicists Giuseppe Cocconi and Philip Morrison published what is widely considered the founding paper of modern SETI research. They specifically identified 1,420 megahertz as the logical choice for interstellar communication. They wrote, and the words have echoed through the field for 60 years. The hydrogen frequency is a unique landmark in the radio spectrum. It is the one that any technologically competent civilization would find significant. So when a mission platform, designed to monitor deep space, detects a narrowband emission at exactly that frequency, arriving from a fixed point in the sky, with internal structure suggesting non-random origin, you don't dismiss that over coffee. You do not dismiss that. This wasn't the first time a signal came through that left scientists speechless, and the history of those moments reveals a pattern that's genuinely difficult to dismiss. Most people who've spent any time down the rabbit hole of space anomalies know about the WOW signal. August 15, 1977, Ohio State University's Big Ear Radio Telescope. Astronomer Jerry Eman is reviewing a printout of overnight data, routine work, the kind you do with one eye on the clock, when he sees a vertical column of intensity values that make no sense. The signal lasted exactly 72 seconds, the full duration that Big Ear could track any fixed celestial source as Earth rotated. It was narrowband. It was strong. It came from the direction of the constellation Sagittarius, and it was at 1,420 megahertz. Eamon circled it in red pen and wrote one word in the margin: wow. It has never been explained. In nearly 50 years of follow-up observation, with increasingly powerful equipment, it has never been detected again. The official position has cycled through several proposed natural explanations, none of which have fully satisfied the researchers who've examined them most closely. A 2024 analysis conducted by Dr. James Pallister at the Breakthrough Listen Initiative, the most well-funded SETI program in history, concluded that of the natural origin hypotheses proposed to date, quote, none adequately account for all observed signal characteristics simultaneously. That's the WOW signal. One data point. One remarkable, unrepeated, unexplained data point. But there are others, less famous, less circulated. A cluster of anomalous detections documented in a 2008 internal review at the Parkes Observatory in Australia that was obtained through a Freedom of Information request and has since circulated in academic SETI circles. 3 separate narrowband detections, different dates, different celestial coordinates, all flagged internally, none reported publicly. The review summary contains a phrase that I keep coming back to. Further investigation deferred pending protocol clarification. Protocol clarification. What protocol, and who clarifies it? What happened after the 2006 signal was logged is, in many ways, more disturbing than the signal itself. Because the response followed a playbook that researchers in this field have documented before. And once you see it, you start to notice it everywhere. Within 48 hours of the initial detection, the mission's primary data stream, which had been accessible to a small network of affiliated university researchers under a collaborative monitoring agreement, was restricted. Access credentials were suspended without explanation. Researchers who attempted to query the data archive through standard channels received automated responses indicating that the relevant files were under review for data integrity assessment. Dr. Alan Berwick, who at the time held a visiting research position at Caltech and had been monitoring the mission's output as part of a broader study on interstellar medium emissions, described what happened in a 2019 interview with the independent science podcast Outer Frequencies. He said, "I'd been pulling data from that archive every morning for 14 months. One day, the login just didn't work. I called my contact at JPL. He sounded careful, very careful. He said there'd been a data anomaly and they were running verification. I said, "What kind of anomaly?" And there was this pause. And he said, "I'm not the right person to ask about that." Berwick didn't hear from his contact again for 3 months. When they did eventually speak, it was brief. His contact told him the mission had been restructured. The data from the relevant observation window had been, and this is the word he used, quarantined. Quarantined. That's a word you use for things that might spread, things that might contaminate other conclusions, or other people's understanding. Despite the official silence, 3 individuals connected to the mission have spoken on record about what they believe was detected. None of them are currently employed by NASA, and their accounts, independently given in different contexts over a span of several years, line up in ways that are hard to ignore. The first is Dr. Berwick, who we've already heard from. His position is careful and measured. He doesn't claim certainty. What he does claim, with great specificity, is that the signal characteristics described to him by his JPL contact before communications were shut down were, quote, inconsistent with any known natural emission source in that region of sky. The second is a former data processing technician who has asked that only her first name be used, named Renata. She worked at the Goldstone facility for 6 years and left in late 2006. In a written statement shared with the independent research group Signals Beyond Borders in 2021, she described the day of the shutdown in terms that are remarkable for their specificity. She writes, "The order didn't come from floor supervisors. It came from 2 levels above where it should have come from for a routine data review. People noticed that. Nobody said anything, but people noticed." She also notes, and this detail has stayed with me, that before the screens went dark, she saw a printout on a supervisor's desk. She only glimpsed it for a moment, but she described seeing a frequency notation and a phrase she didn't understand at the time. The phrase was, "Origin unresolved, pattern non-stochastic, non-stochastic." That means not random. The third voice is the one I mentioned at the beginning of this. A former communications systems engineer who spent 12 years working on deep space monitoring infrastructure before retiring in 2014. He gave a recorded interview to a documentary filmmaker in 2022, footage that has circulated in limited form online. He doesn't make dramatic claims. He doesn't use words like aliens or cover-up. He just tells you what he saw and what he was told afterward. He says, "There was a detection event. I'm not going to characterize it beyond that. There was a detection event, and the response to it was not standard. The response to it was immediate and came from outside the normal chain." He pauses here, long enough that the interviewer starts to speak, and then he continues. "We were told to stop looking. So we stopped." When word quietly circulated through the SETI research community in the months following the shutdown, the reaction from some of the most credentialed astronomers in the world was not skepticism. It was something closer to grim recognition. Dr. Sofia Andrade, who directs the Center for Technosignature Research at Arizona State University and has published extensively on institutional responses to anomalous detection events, describes a culture within mainstream space science that she calls reflexive minimization. The idea is simple. When something doesn't fit the existing framework, the institutional default is not to investigate harder. It's to find the least disruptive explanation and move on. The problem, she said in a 2024 lecture that's available in full on the university's public archive, is that reflexive minimization and deliberate suppression look identical from the outside. Both produce silence. Both produce redirection. The difference is intent. And intent is the one thing you cannot recover from incomplete records. Read that again. Intent is the one thing you cannot recover from incomplete records. She's not accusing anyone of a conspiracy. She's describing a structural problem, a way that institutions, by touch, through entirely understandable human impulses toward caution, career protection, and procedural comfort, can collectively produce outcomes that look, to anyone paying attention, exactly like a cover-up. And the SETI community has been paying attention for a long time. Jill Tarter, one of the most respected figures in the history of SETI research, the scientist who partly inspired the character Ellie Arroway in Carl Sagan's Contact, spent decades advocating for a formal international protocol for exactly this scenario. A detection event. What do you do? Who do you tell? Who decides what the public knows, and when? The protocol exists. It was drafted. It has been discussed at the highest levels of international scientific cooperation, and one of its central, quietly controversial provisions is that in the immediate aftermath of a potential detection, information should be restricted to a small verification team before any public disclosure. The reasoning is scientific. You don't want a false positive to trigger global panic. You want certainty first. The problem, as Dr. Andrade and others have pointed out, is that verification has no defined endpoint, and a protocol designed to ensure accuracy can, very easily, become a protocol that ensures permanent silence. There's a framework that puts all of this into a context that is, somehow, both deeply comforting and profoundly terrifying, and it might actually explain why, if something was found, the people who found it chose to say nothing. It's called the Fermi paradox, and if you haven't encountered it before, brace yourself, because once it gets into your head, it doesn't really leave. The universe is approximately 13.8 billion years old. It contains somewhere between 200 and 400 billion stars in our galaxy alone. Conservative estimates suggest that tens of billions of those stars have planets in what scientists call the habitable zone, the orbital range where liquid water, and therefore life as we understand it, could exist. Given those numbers, given the sheer statistical enormity of the cosmic stage, the universe should be loud, teeming, buzzing with the radio signatures of 1,000 civilizations at various stages of development. And yet, silence. That's the paradox. Enrico Fermi, the physicist, reportedly asked the question at a lunch conversation in 1950. Where is everybody? 3 words. And in the 7 decades since, no one has given a completely satisfying answer. But some of the proposed answers, the ones that serious researchers take most seriously, are the ones that keep you up at night. One class of solutions to the Fermi paradox is called the dark forest hypothesis. It's most associated with Chinese science fiction author Liu Cixin. But the underlying logic is taken seriously in certain corners of astrophysics and astrobiology. The idea is this: the universe is silent not because civilizations don't exist, but because civilizations that survive learn very quickly not to broadcast. Because broadcasting, announcing your presence, is dangerous. Because the universe may contain actors who respond to signals not with curiosity, but with something else entirely. Now, I'm not telling you that's why NASA shut down the mission. That would be speculation beyond what the evidence supports. But I am telling you this: if you were a senior official at a space agency and something came through your instruments at 1,420 megahertz with internal structure suggesting non-random origin from a fixed celestial coordinate, what would you do? Would you call a press conference, or would you, very quietly, turn off the screens? Piecing together the declassified fragments, the witness accounts, and the technical parameters that have quietly appeared in academic papers since 2008, a picture begins to form. And it raises questions that mainstream science hasn't fully answered. Here's what we can say with reasonable confidence, based on documents that exist, statements that are on record, and patterns that researchers have independently identified. In September 2006, a NASA-affiliated deep space monitoring operation detected a radio signal at 1,420 megahertz, the hydrogen line, arriving from a fixed celestial coordinate. The signal exhibited characteristics described internally as non-stochastic, meaning it was not consistent with random noise or known natural sources in that region. Within 48 hours of the detection, data access was restricted, affiliated researchers were cut off, and the mission was restructured in ways that have never been publicly explained. 3 former personnel connected to the event have spoken on record. Their accounts, given independently across a span of years, are internally consistent. None of them claim certainty about what was detected. All of them express certainty that the response to whatever was detected was unusual. A 2025 paper published in the International Journal of Astrobiology by Dr. Marcus Holt of the University of Edinburgh's Institute for Planetary Science examined historical patterns of anomalous signal responses in NASA-affiliated monitoring operations between 1995 and 2020. His conclusion, cautious, heavily caveated, but present, was that there exists, quote, a statistically improbable clustering of access restrictions and mission restructurings in the months following flagged narrowband detection events. He stops well short of calling it deliberate suppression, but he calls it a pattern worthy of serious institutional scrutiny. A pattern worthy of serious institutional scrutiny. That's academic language for something is wrong here, and we need to talk about it. Now, the natural explanation that gets offered most often, and I want to be fair to it, is radio frequency interference. RFI. Human-made signals that contaminate deep space observations. It's a genuine and persistent problem in radio astronomy. Ground-based transmitters, satellites, aircraft, they all pollute the radio spectrum, and a contaminated dataset is absolutely a reason to restrict access while you run verification. But here's the thing. RFI contamination is documented routinely, openly. It's logged, explained, corrected, and published. It is not, in the normal course of events, the kind of thing that triggers multi-level access restrictions and mission restructuring. And it is certainly not the kind of thing that prompts a senior official, 2 levels above the normal chain, to show up on a facility floor and issue shutdown orders. Something happened. The question, the one that nobody with institutional authority has chosen to answer, is exactly what? Now, I want to be honest with you here, because the easy thing would be to lean all the way into the conspiracy angle, to tell you that this is proof of a decades-long cover-up, that NASA knows exactly what's out there and has decided, unilaterally, that you can't handle it. That would make for a satisfying story. It would also be intellectually dishonest. The truth, as best as I can present it, is more complicated than that, and more interesting. Institutional secrecy and institutional incompetence often produce identical results. Bureaucratic caution and deliberate suppression are, as Dr. Andrade said, indistinguishable from the outside. NASA is not a monolith. It's a massive, underfunded, politically pressured organization staffed by thousands of people with competing priorities and incomplete information. The idea that any signal of genuine significance could be cleanly suppressed across that entire ecosystem, permanently, without leaks, without documentation, strains credibility. And yet, the documentation that should exist, the routine, transparent, boring paperwork of science doing its job, is not there. The data from that observation window has not appeared in any public archive. The mission restructuring has not been explained. The researchers who were cut off have not received answers. Mainstream scientists, the ones who operate entirely within the consensus framework, will tell you this is unremarkable, that archival gaps are common, that mission restructurings happen for funding reasons, that former employees with grievances sometimes construct narratives. All of that is fair. All of that deserves to be part of your analysis. But here's what I'd ask you to sit with. If a narrowband signal at 1420 MHz with non-stochastic internal structure was detected and then definitively ruled out as significant, why is there no public record of the ruling out? Why is there no paper, no technical memo, no official statement that says, here is what we found, here is why it was terrestrial interference, here is why it doesn't matter? Absence of evidence is not evidence of something extraordinary, but absence of explanation from institutions that are supposed to explain is worth noticing. Whether this was a genuine detection event, an instrument anomaly that caused institutional panic, or something else entirely, the story of this mission leaves us standing at the edge of a question that humanity has never been fully ready to answer. Are we alone? It sounds simple. It's not. Because buried inside that question are 1,000 others. If we're not alone, what does that mean for everything we've built? Our religions, our philosophies, our comfortable assumption that the story of consciousness in the universe begins and ends with us. What does it mean for the choices that governments make, and the information they decide their citizens can and cannot hold? There's a researcher, Dr. Priya Nair, an astrobiologist at the SETI Institute in Mountain View, California, who said something in a 2024 public lecture that I think about more than almost anything else in this space. She said, "The question isn't whether we'll find evidence of life beyond Earth. At this point, the scientific consensus is that it's a matter of when. The question, the one we've never seriously prepared for, is what we do with the answer when it arrives." She paused, and then she said, "Because we will have to decide, in that moment, who we are." Who we are. What happened at Goldstone in September 2006 may have been nothing, a data artifact, a malfunction, a bureaucratic overreaction to an ambiguous result. That is, genuinely possible. I won't pretend otherwise. Science is full of moments that looked significant and turned out to be noise. That's how science works. But what if it wasn't? What if, somewhere in a restricted archive, there are logs from a Tuesday morning that describe the first confirmed instance of structured, non-random signal arriving at humanity's doorstep from somewhere we don't yet have a name for? What if the screens went dark, not because of what the signal was, but because of what it implied? What if the question, the oldest, largest question we've ever asked, got answered? And the people who heard the answer decided, for reasons that may have seemed entirely reasonable to them in that moment, that the rest of us weren't ready? That is not a comfortable thought, and it shouldn't be. Because if that's what happened, the real story isn't about the signal. The real story is about the choice to listen, and then go quiet. The choice to sit at the edge of the greatest discovery in human history and pull the curtain. And the question that leaves us with, the one that I don't think has a clean answer, is this. If you were in that room, if you were the one who heard it, what would you have done? The universe is 13.8 billion years old. It is incomprehensibly vast. It has been making signals, of all kinds, since long before there was anyone to receive them. And somewhere in that vastness, in the noise and the static and the hydrogen line that hums at 1,220 megahertz like a beacon that physics itself put there, something may have spoken. Whether anyone was allowed to listen is the question that keeps the lights on in this particular corner of human curiosity. And I don't think we've heard the last of it.